Hi, welcome to Hi So Math Creations. I'm April So, and this is a channel where I make math help videos to help you ace your next math test. This video is part of a 2-video series where we go over an entire test from start to finish on quadratic functions. We will be looking at section 2, which is the calculator section of this test. The calculator we're using in the class is the TI 84 Plus CE. Let's begin. So question number 5 asks us to solve for n. First, we want to set the equation equal to 0. Then we are going to go into our calculator. Yeah, so we have two options here. We can use the PolySimult app or we can solve by graphing. Unfortunately, the online graphing calculator simulator that I'm using currently doesn't have the PolySimult app. So I'm going to go ahead and graph this equation and figure out the x-intercepts from my graph. Okay, so you can see I've graphed my parabola, but I don't have a really good window. Let's go into our window setting and adjust this. So I noticed that I need to see more x values, so let's make the x maximum higher, let's make that 20, and I need to see some more y values as well, because I can see the top part of my graph, so let's also make that 20. Let's see what we get. Okay, so I can see that my vertex is way up somewhere in the positive x. It's still way higher, so I need to set my window, change my window settings again. Let's change the x maximum to 50, and let's change the y maximum to 50 as well.
1 hour later.
Oh boy, okay. Try it again. Okay, so I'm gonna go ahead and enter my quadratic equation in the y equals menu. And let's go and graph our parabola. We're gonna click second trace to go to the calculate menu, and we're looking for the zeros of the function. So our first set of instructions is asking us what is the left bound. So I'm trying to solve for this first x-intercept, the one on the very left. So I need to make sure my cursor is to the left of that x value, press enter, scroll until it's on the right of that value, press enter again, press enter a third time, and I get that my first answer is going to be n equals negative 1.53. Okay, so notice in the instructions, I've been asked to round all my answers to 3 significant figures. And then let's go ahead and follow those same steps to find the second x coordinate, or the second x-intercept. Okay, and here we arrive at an answer of x is equal to 0.654. And we're done. Next question. The table below shows some inputs and outputs of functions f and h. In question 6a, we're asked to find f of 0 plus f of 1. So in order to find f of 0, I look at the table that represents function f, look for the input value of 0, and then write down the corresponding output value. To find h of 1, I look at the table representing the h function, look for the input value of 1, and write down our corresponding y value, the output value. From here, we simplify. Negative 3 plus 2 is minus 1. The next question asks us to find h of f of 1. So another way to express this is as follows. First, I want to find f of 1. So we work from inside to outside. F of 1 is in the table here. So look for the x value of 1 and where the y value is going to be. So when x is 1, our y value is going to be minus 1. So f of 1 is minus 1. Now I want to find h of negative 1. So look at the table representing h, and we can see the output value for this is 0. So last question asks us to find f inverse of minus 3. This is another way to say that we need to figure out what the x value is in function f when the output value is minus 3. So I look for all the y values, and I can see that when f is equal to minus 3, the original input value is 0. So that means f inverse of negative 3 is 0. Question 7. A coffee shop sells only coffee and in only one size. The shop's daily profit P in dollars is given by P of x is equal to negative 200x squared plus 1,600x minus 2,320, where x is the price per coffee in dollars. First question, find P of 0 and explain what your answer represents in the context of the question. So when I make x equal to 0, I get a profit of minus 2,320. Now this likely means that the coffee shop has to invest an initial cost of $2,320 in order to set up their shop. This might include things like buying the equipment, getting the coffee, hiring people. So we can write here that this value represents the starting cost for the coffee shop. B, what is the maximum possible daily profit, and what would the price of one coffee be to achieve this maximum profit? Great, so now again, we can go into our calculator, and now let's input this new function. So here we want minus 200x squared plus 1600x minus 2,320. So in our graph, and you can see I definitely need to adjust the window here. I'm not seeing enough positive y values in order to figure out what the maximum would be. So going to our window, we can change x minimum to 0. I don't think that the coffee prices are going to be less than 0. Otherwise, the coffee shop not going to make any money. And let's change our y maximum to, let's start with 100 and see what happens. Okay, so you can see I'm still not at the maximum point of the crowd so let's go ahead and adjust this again. Let's double this number for y maximum and see what happens now. Okay, getting close, but still not quite there where I can see the next on my screen. So we're at 500, getting closer, 600. Okay, let's start 800. Almost okay, let's just go ahead and change this to 1,000. Now we go second, calculate menu. We're going to look for the maximum, that's option 4, and follow the instructions on the screen. So select a point to the left of the vertex, select a point to the right of the vertex, and press enter one last time. And we can see our maximum profit here is 880. The price of the coffee to achieve this max would be $4 if I round. Okay, the next question asks us to find the lowest price per coffee, so that's an x value, for which the profit is 0. So that tells me I need to find the first x-intercept here that I see, and I need to give my answer correct to 2 decimal places. So let's go ahead and go to our calculate menu. We're looking for the 0, and this time I want to scroll until I'm to the left of the first x-intercept, then to the right, press enter, and I get that the lowest price of coffee, which would result in, so the lowest price per coffee for which the profit is 0 is going to be $1.90, rounded correct to 2 decimal places. Even though there's 2 solutions on my graph for which profit is 0, this question is asking the lowest price per coffee. Question D. Find P inverse of 80 and explain what your answer represents in the context of the question. So we have another inverse question, and this 80 represents the output value, which means a profit of 80. So we're asked to figure out what the original price of the coffee has to be in order for the shop to make a profit of 80. In our graphing calculator, we can actually go back into our y equals setting and look for when profit is 80. So we can draw a line at y equals 80, and we can see that there's actually 2 solutions here. So there's 2 points of intersection. We go to second, trace to get to the calculate menu, look for the point of intersection, and find the x values, or the prices of the coffee, that make the profit 80. Here's the explanation. So this means that to achieve a profit of $80, the coffee should be priced at $2 or $6. Question 8. A town is holding its annual music festival 6 months from now. Based on last year's ticket sales and survey results of how many tickets could be sold at different prices, a study group collects the table below. Variable C represents the cost of the ticket in dollars, and P represents the estimated overall profit in thousands of dollars that the town would make at that ticket price. So here's the table of values. Notice that we have been given the variables. which are C for cost and P for profit. Question A asks us to find a regression model in terms of C and P that give the estimated profit in terms of the cost of the ticket. So here we can use our graphing calculators to help us find the regression model. In the first step, we got to go to Stat, click Edit. We enter all the independent or X values in list 1. We enter all of the Y or dependent values in list 2. So in this case, our independent variable is cost, our dependent variable is profit. Once we have entered all our values, we are going to go back to Stat, scroll over to Calc, and look for quadratic regression. We can also go into Store Regression Equation by clicking Vars, scrolling over to Y-vars, selecting Function, and selecting Y1. This allows us to store our regression equation without having to copy down all of these coefficient values in our y equals menu. And we can see that our equation gives us P equals negative 0.0907 c squared plus 7.84c minus 137. All of these coefficient values and the constant have been rounded to 3 significant figures, and notice that we're also using the variables that are presented in the original equation. The coefficient of determination is the r-squared value that's given in our calculate screen. This is 0.983. So we have an r-squared value very close to 1, meaning that our model is a good fit for the data. Question C. For what ticket costs would the profit be 0? Give your answer correct to 2 decimal places. So now that we have our regression equation, and luckily we have it stored, so we don't have to go back and copy out all those numbers again, we simply go to our graph, make sure again you have a good window setting, and we are going to look for when this equation, or when our parabola hits the line y equals 0. And we can see that there are 2 points which make that true, and that is for a cost of $24.25 or $62.15. The last question says, find the values of C such that P of C is greater than or equal to 0. So when would this parabola, or when would our profit be greater than or equal to 0? Well, we can see from our graph that has to occur in between $24.25 and $62.15. This is how we would write that, okay? Algebraically, we would say $24.25 is less than or equal to C, which is also less than or equal to 62.5. In other words, that is the range of values for C that keep the profit greater than or equal to 0. Final question. A farmer is constructing a pig pen and is using his barn wall as one side of the pen. If he has 32 meters of fencing and wants to use it all, write the quadratic function that models the area of the pig pen and use it to determine the maximum area of the pen. Be sure to define your variables. Let's start with a useful diagram. So let's define some variables first. Let A be the area of the pen. Let X and Y represent the length and width of the pen, respectively. Since we're given 32 meters of fencing, one of our equations has to be that 32 is equal to 2x plus y. Notice that we have 2 sides of length x in our pig pen and 1 side of length y in our pig pen. Using this equation, we can rearrange it to solve for y, and you'll see why this is useful in a moment. We can write a second equation representing the area of the pig pen, which is x times y. Let's now replace y in our area equation with 32 minus 2x. This gives us a new equation
written explicitly in terms of x, or area. Here's what the graph of this area function looks like. You can see that it has a vertex at 8, 128. This means that when one of the lengths is equal to 8, the maximum area is going to be 128 meters squared. So we have our answer here. Therefore, the maximum area is 128 meters squared. And we are done.
Two factors, when they multiply to make 0, either one of the factors has to be 0, or the other one has to be 0, or both of them.